All righty, we are on time. Welcome everyone to our Data Visualization Design Essential with Kristan Hodge. Kristan Hodge is an experienced leader, designer, researcher, and problem solver. Kristan leads the Accessibility Center of Excellence and teaches data visualization through Upton's Data Science University. I have been in Kristan's presentations before, so I know you are in for a treat today. In this session, she will share what do you need to know to make good decisions about data visualization designs. We will uncover some of the mysteries of visual perceptions and cognitive overload, work through a simplification exercise, and send you off with information about where to find resources. You will be better prepared to share your data aha moments and add clarity for decision making. Welcome, Kristan. It's wonderful to have you here at our very first MinneWiADS conference.
Thanks, Diana. I'm happy to be here. Hi, everyone. Thanks for joining. I guess I don't need to introduce myself, so I will just move on. Okay, so we're all here because we love data, right? Chances are everyone has a set of data or multiple sets of data they continuously update and review. We each know our own data inside and out, but now what do you need to do? Probably you need to share your findings. Maybe you need to help others gain knowledge. And maybe you're trying to help other people make decisions. Now, these days, everybody does data visualization. You know, it used to be the realm of the experts. Data scientists were the only people creating visualizations. But now we all have tools on our desktop that make it really easy. Everybody's got Excel and we're all expected to be able to use it. The problem is most of us haven't been trained in how to communicate with data or even to interpret what we see. So how does data visualization work? It's really a two-step process where you've got your data source and you encode that into a visual representation. And then your viewer decodes that, hopefully gaining understanding from that. So what we're going to do today is work it backwards from the decoding process so that you better understand how it's being interpreted, and that gives you better choices in how to encode your data. So what do we need to know? We need to know basics about visual perception and cognitive psychology, a little bit about storytelling, and a little bit about visual design best practices. So I'll walk you through some visual perception and cognitive psych. We'll talk about storytelling a little bit. What are the elements of a good chart? Some pitfalls you can avoid. We'll walk through some sample makeovers, and I'll give you a list of places where you can go to learn more. So after this session, you should be better equipped to make good design choices when communicating with data, and you should be able to explain the reasons for your choices. So hopefully I'll be taking some of the mystery out of it, and you'll leave feeling more confident in your ability to communicate effectively with data. So a little bit about visual perception and cognitive psychology. So this is a really simple view of how visual perception works. Somehow out in the environment, there's a stimulus. It could be a physical object. It could be on your screen. So if it's a physical object, light is reflected off that object into your eye. If it's coming from your screen, it's emitted from the computer. This is received in the retina at the back of your eye, which travels through the optic nerve into the brain. And the brain does some pre-processing for you. You don't even know this is happening, but it picks out features from the scene that might be of interest. And then it looks for patterns. And it takes those features and those patterns and it puts it into your working memory. And this is where you become aware of what you're looking at. So a little bit more about how we see. We see only a small part of the visual spectrum. You can see here blown out into what we normally think of as a rainbow. But we don't all see it the same way. So let's talk a little bit about color blindness. So here's an image that has lots of reds and greens in it, and I use this for a special reason, which I'll show you. About 8% of men and 0.5% of women experience deficiencies in color vision. And the most common form of that falls on the red to green spectrum. And this isn't all or nothing. This really is on a spectrum. And so people will have more or less difficulty seeing red and green. So here's the most common form of color blindness called protanopia. And this is deuteranopia. You can see how the red and green are missing from those rainbows and from the image above. And then here's a rare form called tritanopia where the yellow is missing. So just important to keep in mind as we're talking about design that not everybody sees color the same way, and this is where we fall down a lot in data visualization. So the first thing your brain is going to do is pick out features. We call this pre-attentive processing because you don't know what's happening, and it's really fast. And so some of these cues that are strong in data visualization are color, orientation, size, and contrast. And so I'm going to step through those. So here's color. And here are 4 different ways that you can use color, basically from most effective to least effective. You can use color as a highlight where only one item has color to help it pop out from everything else in the view. You can use color intensity where the darker color means there's more of something and the lighter color means there's less of something. You can use color purity or saturation where it's all the same level of luminance, but if it's all solid color, that means there's more of something, and if it's just gray, that means there's less of something. And then there's hue variation, which is what we see a lot of. According to studies of visual perception, most people can distinguish a maximum of about 12 colors from each other. There are 12 colors here, and I created this palette from a palette generator that claims this would be safe for colorblind users. And we'll get back to that later. So another feature we spoke about is size. And depending on how size is shown, we'll have varying levels of success in judging it. So the most accurate is length, where all of your items start at the same space. In here, columns all start at the same baseline, and your bars all start at the same baseline. It makes it really easy to tell which one is longer than the other one, easy to judge. But when you start stacking them down here to the left, that second layer is really hard to compare because they have different starting points. We're even less accurate in judging areas. So here, the tree map in the middle would really be best if it's labeled. If it's just there to give you a gist of the scene, that's fine, but you'll have a lot of trouble telling the difference between the sizes of a lot of these boxes. And then we're even less able to judge angles. So pie charts are the least accurate for interpretation. So I generally veer away from those, and they're okay if you just want a sense of something, but if you need accurate representation, you're going to have to directly label. The next is contrast. This is a fun exercise. On these 3 rows, there are 3s in there, and I'm going to give you about 10 seconds to pick them out and count how many there are. Okay, so if I highlight the 3s using color, for most of us, they'll be easier to pick out now. It's pretty easy to see that there are 7 of them. What we find a lot of people when they realize this, they think, oh, well, we'll just give every number its own color and that'll make it so easy. But in fact, that makes it much harder. And you just wind up with a cacophony of color and none of it helps, right? So you're better off with everything just being gray in this case. But you can do this without color as well. So here's a different way to look at it. These are all gray. You could make the 3s bold and black. And then if you wanted to further draw attention, you could put a gray background behind it to help them jump out. Another thing we need to look at is different kind of contrast. Here you've got, at the top row, you've got black, gray, and white, pretty easy to tell apart. When you get to the second row down, there are 5 levels, and this is about where our visual systems start breaking down and having trouble telling the difference. If you look at that middle row, it's getting a lot harder to tell the difference between the shades of gray. And further, your brain is trying to find the edges of objects all the time. And so if you look at the borders, the left edge of the lighter color looks lighter, and the right edge of the darker color looks darker, and it creates a sort of gradient effect. But that's really just your visual system playing tricks on you to help you see the edges of things. But as you go down into the lower rows, you can see that actually makes it get harder and harder to tell the difference between these. So you're best off limiting yourself to 5 different shades if you want good contrast. There's also the problem of simultaneous contrast. So if you look at this little box above, and I place it on different gray backgrounds below, you can see how it looks different in different settings, and yet it's the same shade of gray. So when you use background colors or background shadings, it's really important to keep that in mind if somebody needs to tell between different backgrounds what the thing in the foreground is. You're going to complicate it a lot if you change the colors or shades of gray in the background. Next, we're going to look at some patterns. So Gestalt principles of visual perception have been around for a while. The first principles were devised in the 1920s by a group of German psychologists. And Gestalt is the German word for unified whole. And these were all discovered through research with people and seeing what things jumped out to them automatically. So we'll look at 4 of those principles. The first is proximity, and we see this a lot. Things that are sort of clustered together are going to be perceived as groups. And that's automatic. The other thing is enclosure. So here, you see how these dots line up into rows because of their alternating shades. But if you enclose some of them in a box, now those things appear to be grouped together, and that overrides the shading of the rows. Another concept is continuity, where again, your brain is trying to find the edges of objects, and so it will prefer to see things as continuing lines rather than, if you think of this maybe being an upper line that comes down and bounces back up, or a lower line that comes up and bounces back down. That is not how the brain will automatically perceive that. This will be perceived as 2 crisscrossing lines. And even if you did it this way with the white dots and the gray dots, that interrupted gray line would still be perceived as a continuous line. And one more, which is connection. So these dots, without any lines connecting them, would all be just a bunch of dots. But once you connect them with lines, they're very strongly related to one another, and that will be something that jumps out right away. So all that's getting put into your working memory, but your working memory has limited capacity. You can really only deal with a few items at a time before you start to get confused or frustrated. So let's look at that a little bit. So if you're looking at 2 items you need to compare and try to understand the relationship between them, that's pretty straightforward. When you have 3, there are multiple different ways those might be related to each other. When you get to 4, it starts to get really complex, the ways you need to look at those things. And once you get past 4, you get into the sort of combinatorial explosion that makes it really hard to determine what are the relationships between things. And this is usually where people give up. So if you're showing 5 things people need to compare and they're not familiar with them, they're either going to find themselves in analysis paralysis, or they'll even more likely just pick out the few things that are more familiar to them and compare those and ignore the rest of the data. So 2 dangerous scenarios there. It's important to understand too that what constitutes one item in working memory has a lot to do with your level of expertise. So here I have an example. Believe it or not, there was a time at which we didn't really have a schema for a tree. We would have seen leaves, some branches, these trunk things, and we might not have noticed they were all the same thing or that they were related to one another. But over time, we came to understand that those things comprise a tree. And so now we have a schema of a tree, and that's one thing, not 3 things. We further have different kinds of trees that we easily recognize, and groupings of trees like orchards and groves and forests. These are things you have to keep in mind. If you're the expert and you understand what a forest is, it might be that your viewer is looking at this leaf and trying to sort things out. And so you just need to know where your viewer is in relationship to where you are so that you can show the right number of things for them to compare, for them to have that aha moment and start to form those schemas so they can follow along with you. Something else we're not usually very aware of is that we're not really looking at the whole scene at one time. This is counterintuitive. We think we see this whole picture at one time, but really you're only focusing on about 2% of the visual field at any given time. So when this picture changes, you're going to notice the changes in the area where you are looking mostly. So we're going to do a quick little exercise here. I've got an A version and a B version of this image, and I'm going to flip to the B version and see how many things you notice changing. Now keep count in your mind, and we'll go back to version A. Think about looking at a different part of the picture. Keep count. We'll look at B. Maybe look somewhere else on the picture. Keep count. We'll go back to A. Okay, and last time up to B. Now, most people, when I poll them, see 3 or 4 changes. I've gone through this many, many times back and forth, and I've managed to count up 9 things that change in between the 2 pictures. So it's just to help you see that if you show a before and after, not everyone's going to see the same things you do unless they're very well trained to look at the same things. So you might need to point out what changed. Let's talk a little bit about storytelling. You need to get to know your audience and make sure they have actionable results, and be careful not to accidentally mislead them. So it's important to know that you are not your audience unless you're only designing for yourself. Most of the time, other people will be looking at what you've produced. And so it's really important to understand their perspective and where they're coming from so that you can do a good job of that. So what do you look for? You might be interested in their role. What is their title? What are their duties? Who else do they interact with? How do they normally communicate? How proficient are they with technology in general? What's their level of expertise with what you're showing them? And what are they trying to accomplish? Where are they within that task flow? What have they already learned, and what's missing to help them complete their task? So there's some ways you can gather this information. You can hire experts to do this. The department I work in does this. But you can do this yourself, and I would encourage you to try it. Observing people in their natural environment is actually a lot of fun if you can get them to let you sit with them and watch. If you ask them to think aloud while they're working, you can follow along with their thought process and take lots of notes. You'll learn a lot. Otherwise, you can interview people, ask them about their task flows and what they're trying to accomplish and what sorts of information they need to make decisions. You could also survey people. And so as you go from left to right here, it's getting less and less robust in terms of the data you'll gather. And it's important to remember that your data visualization is only part of the larger process. So you need to know where they're coming from, where they are in their task flow, and what they're looking for to get to the next space in their task flow. And then what are the outputs? What decisions and outcomes are you influencing? And how are you making sure that you're influencing those in the most positive way and not taking people down strange paths that won't help them make their decisions? Something else to keep in mind, not everybody's at the same level of literacy in terms of reading and writing the English language, but also in our case where I work, health literacy is a big deal. Not everybody understands even basic health terms. And then numeracy, not everybody is good with numbers. So that's something else to keep in mind, and this runs across all people. So as a reminder, make sure that you don't overload people cognitively. Make sure you're not giving them too many things to think about. They will struggle with it. Make sure you know what represents novel items to them. Give them just a few, and they'll be able to figure it out and get to the next step. For storytelling, you want to make sure you're setting up the context so that whoever's viewing your visualization understands the context in which it is to be reviewed. If you can walk through some scenarios, that's very helpful. Show people how they might look at the data. What are the possible ways you could evaluate it? And then what's the call to action? Now that you've done that evaluation, what should you go do? Now, how can you take action on this? And just a quick reminder about misleading with data. This is a simple set of data I put into Excel, and it popped out this column chart, which looks just fine. You know, it looks like you could just copy this, put it into your report, send it as an email, whatever. But if you think about it, Excel has done something that's a little bit naughty in a way. It has zoomed in to help me see the differences in my data. But as we talked about judging lengths or heights of columns before, if we look at this, it looks at Madagascar here on the far left compared to Libya is less than half of Libya, right? So that looks really bad. But we're zoomed in, so we're looking at only between 80% and 98%. If we need to compare those lengths, we really need to make sure they're starting at the same place, which is 0. So if you start them at 0 and go up to 100 now, you can see the difference isn't so exaggerated. The difference is really only 7%. So important to keep in mind. Okay, this should be pretty straightforward. Why do we care about good design with our charts? We want them to be predictable. We want to make sure we're always setting context. It establishes credibility if it looks the way people expect, and if it's consistent, people will be more efficient and accurate in interpretation. So basic chart elements, we probably all know these: title, subtitle. You've got your axes labeled. The only place in which I would suggest turning the label sideways is when you're labeling the y-axis. Otherwise, everything should be horizontal for easier reading. In a word about legends, if you can avoid them, do. When you have a legend off to the side and a bunch of lines or dots to the left, the user has to go back and forth, back and forth, back and forth, trying to sort it out. It's best if you can just directly label things and get rid of that extra cognitive load. There are standards for how you should align numbers and dates, so this is just a quick reminder. Text should be left justified, numbers should be right justified, and they should be right justified at the same level of precision. So if there are commas or dots, it should all line up vertically. And then, of course, if there's no data, it's good to indicate that there are no data in those left blank on purpose. So here's some quick pitfalls to avoid. The first is 3D. This definitely skews perception. So I'm going to have a sip of coffee and ask you to look at ovarian cancer here and think about what percentage that looks like. So most people, when we do a poll, guess 4%, but it's actually 5%. So you can see, because it's set out at an angle from the line for 5%, we don't really see it that way. It looks cool, but it's not accurate for interpretation. So you're best off flattening that graph. Now you can see it exactly lines up with the line for 5%. You've got a long label over here though, so I would actually turn that sideways. And now you've got all these lines and numbers down here. You could actually clean that up by just directly labeling your bars. And now you've got a before and after. You can see one is easier to interpret than the other, even though one looks fancier. And the other thing we see a lot, as I mentioned before, is overuse and misuse of color. So using colored backgrounds makes it harder to distinguish the colors on top. Using too many colors means you just can't interpret it. Unnecessary color variation, we see this a lot. This is probably just one set of data, and these bars, columns should all be the same color. There's no reason for them to be different. And then accidental color pairs. So here's that 12 color palette I showed you before. If you mix up those colors and put them next to the ones that look most similar, you see you've got 2 of these olive greens, 2 oranges, 2 bright greens, 2 pinks. And what happens psychologically when you notice these things in a visualization, you tend to think that those things are related to one another, even though they probably are not. So it's something to be careful to avoid. If you don't want people to be thinking of those 2 things as related, try not to use so many colors and try to keep them very different from one another. If you find yourself falling into this trap, or you're working with somebody who constantly wants to use lots of colors and you want to dissuade them or dissuade yourself, here are a couple things you can do. You can run your image through a color blindness simulator online, and there are several. So here you can see how well you did there. You can also just switch it to grayscale and see how well you're doing on contrast in general. Pretty much if you can't tell it on grayscale, you should go back and rethink what you're doing. Something else we see in the corporate space a lot is overuse of stoplight colors, red, yellow, and green. And as we know, red and green are the most likely places people are going to have trouble distinguishing them. So if you run this through a color blindness simulator, you find that the red and green look almost exactly the same, and now what jumps out is the yellows, which is probably not your intention. So as a reminder, here are those ways that people see the visual spectrum. And if you just pull out the reds and greens, the differences are really obvious. So something to be careful of. So what can we do? So some alternatives for the stoplight colors, you could instead use symbols that are open, half closed, and closed. But usually you don't need to draw attention to the things that are green. Those are doing fine. So you don't need to draw attention to them. Maybe just show the things that do need attention and maybe need attention. Or just draw attention to the one thing that needs attention. Similarly, we often see in grids people using colors. And this makes it hard to read, actually, and it's really overwhelming. You don't need to use color at all. You could remove those colors, and instead, the things that might need attention or do need attention could be in bold. And you can use outlines, bold outlines and small outlines, to help draw the eye to the right places. Okay, we just have 5 minutes or so left, so let's do some sample makeovers. If I can get it through. Okay, so Excel typically puts out something like this. Lots of colors, lots of lines, very cluttered looking. So we can remove the grid lines to get a better view of the data. And we could align the tick marks to the numbers below. Then we could add labels to the final point and get rid of that legend. That helps. Now we could add values to the beginning and the end with the assumption that maybe what's going on in the middle is just a pattern that's interesting and we don't need to have number labels on every single point. And now that we've done that, maybe we don't need that vertical axis anymore because they're labeled. We can get rid of that. Now we can increase the font size to make it easier to read. Maybe give it a title. And then figure out what's the thing that's most interesting. What are we looking for here? Let's just say that category 1, that spike in the last year for category 1 is the thing that's most interesting. So let's highlight that line, making it bolder, make the labels bold, and de-emphasize the others by making them gray. So now we can add a subtitle for context and the source. This was invented. So now we can put those side by side. So here's another one. Let's go back to that column chart that had too many colors in it. And we can just remove those unnecessary colors. You wouldn't have to use color at all, but people tend to like to see one color, so we have one. These labels are hard to read when they're at an angle like that, so let's rotate the whole thing. That font size is pretty small. We can make that bigger. It's still not easy to read. We can make it darker. But now, do we really need that grid, that line there with all the numbers on it? Probably not. These are directly labeled bars. Now we've got this border that's not helping us out. Let's get rid of that. Now we can really start thinking about what should we do here? Should these be ordered in some way? So let's try largest to smallest. Now what do we do with that? Okay, do they deserve special attention? Maybe if you had a target or a baseline or a threshold, that would help tell your story. So if we add a threshold, there we go. Now we see 2 are past the threshold. So how do we draw attention to them? Other than that, they're past the line. You could try adding a dot there to highlight it. We were showing dots before. That kind of helps. Or maybe use the highlighting method where color shows the one you should pay attention to and lack of color shows what you don't need to pay attention to. So they stand out a little bit better this way. So there's a before and after. I've got one more for you, which is a table. So let's look at this table. Now, at first glance, there's nothing really terribly wrong with this table. It's clear, it's not cluttered with color. The text is left justified, the numbers are right justified. It is kind of busy though. So we'll start here at the headings. The alignment should match the content below, so we'll just quickly fix that. And then all of these zeros are making the numbers hard to read, and there are a lot of them, so we could hide those. That makes it easier. Now, when I copied this from Excel into PowerPoint, it got rid of the padding inside the cells, and you can see how the numbers are just clinging to the lines, which makes them harder to read. But because they're nicely lined up, we can probably get rid of those vertical lines. So there they go. But now it's hard to tell where the groups are. So let's try lightening the within group horizontal lines. And that helps with the grouping. It's a lot less busy now. There's one thing left that I think I want to do here, which is remove the background on the header. And this is because it's not really terrible to have it highlighted like that, but it actually creates some cognitive load when you're looking at black text against a white background and then white text against a dark background, and you cognitively have to switch between what's foreground and what's background, and that's confusing. So we can just remove that. But now you got some things floating up there, so let's get them down along the baseline and make them bold. So that helps. Okay, so now what can we do with this? Oops. What's the story here, right? We got it cleaned up, but we still can't tell what the story is. So there are a few possibilities here. Maybe this is a celebration. A few of these had 100% on their within remediation timeline. But some of them were pretty low. So maybe are we looking for where we missed our SLAs? Or are we looking at the ones that have unusually high volumes? Once you've cleaned up your table, it's really easy to highlight these and make them stand out. So there we have our before and after table cleanup. Okay, and where can you learn more? So here's a list of possible external resources you might find in books, communities, tools, training. I've put a dot by 3 of the books that I think are probably the easiest place to get started if this is new for you. Otherwise, this is a good list of references. And there we go. Time for Q&A. Just a few minutes left.
Thank Kristan for the wonderful presentation. I appreciate it. And I can see from the chat, everybody's enjoying the event. One question, you know, we have all of these great practices and we want to do it in our data visualization practices. But when you go to do this and when you get a question from the business, sometimes you get more flexibility. They would tell you, this is what you want. Tell me, provide me a report. That's easy. So you get the flexibility to practice all of those things. Mm-hmm. But other times the business has an agenda and they would tell you, no, I don't want that. I want this. So how do you find that balance? Because we know the best practices, we know sometimes what they are asking is not the best way to present the data. So how do you have that conversation?
So here's the way I normally would approach that is do the version they ask for, do your own version that you think might be better, and explain why you made choices to try it a different way. And sometimes you can convince them. Sometimes you can't. I did have one executive who insisted on the red, yellow, and green background colors. Couldn't get away from that, and that's that person's choice. That's what they like to see. So you can't always win those arguments, but at least when you have this information, you can present an alternative and explain why you tried an alternative, and sometimes you can convince people.
Thank you, Kristan. I have questions in the chat window, and someone asking, what data visualization tools do you use and also prefer?
Oh, I mostly use Excel, actually, because I'm not into big data, right? I work in user experience design, and so when I'm creating examples, I usually work in Excel, sometimes Tableau.
Right, there's a lot of chat going on saying this is groundbreaking and it's going to help them a lot.
Good, I hope so.
Yes, and let's see. Does your whole team leadership buy into this type of data representation? How would you push back on the norm? It's kind of like what we touched on.
Yeah, similar. Yeah. I've had other people ask too, like if people just come to you and say, I need a pie chart that has this, you don't have that information about where they are in their process or what they're trying to do with it, and it's kind of hard to help them if you can't get that information.
Great. Let's see. What if you have data, let's say that last table where you wanted to highlight a few key findings. For example, team members with 100%, team members with low percentages, and team members with high volume. Is it best to create 3 versions of the table?
I probably would, just because they're different things. But you could find a way to show those. For example, if you wanted to use a symbol in front of names, you could do that. 3 different symbols, and it would only show on the people for whom those things applied. So not everything would have a symbol. That's one way to do it. Color coding is a little bit risky, as we know. You can also show them all in bold.
And sometimes you have those, so they follow the data practices, but then it's still, you have to scroll down the pages and pages because everything in a one screen, they want to fit everything in a one screen. So what would you say?
About the infinite scroll?
Yes.
I hate the infinite scroll.
Me too, but some people
but I'm
do
old.
like that.
Yeah, I think the younger generation is a little bit more receptive to the infinite scroll than us older people. There are ways to make it more condensed or possibly drill down instead of the infinite scroll.
And what's your best advice for side-by-side data? So you could do the same representation twice instead of adding a filter or something, or you could do a filter too. So when I think about a visualization, if it is the same thing, but for 2 different categories, let's say sales by the category, and I'm showing for the shoes and then the clothing in 2 separate graphs, but it's the same thing. What I would usually do is, okay, let's add a filter there. So if the users want to select it, they can select it rather than showing the same thing on the screen. But you do sometimes get that request to, what would you say? What's your preference?
Sometimes it's useful to do this side by side, actually, but when you do that, you need to make sure that you're using the same scale so that you're actually comparing them in the right way. So if they're side by side, the vertical scale should be the same so that you're actually getting an accurate comparison. And that leads to small multiples too, right? Sometimes you see a whole bunch of little ones on a screen and they all need to have the same scale if you're going to compare them.
Yeah. With Tableau, I see this a lot. There are amazing dashboards, but then there are a lot of line charts, very small ones on top. They look very pretty, but I don't know how much you can comprehend from it. What do you think about that?
Something like sparklines?
Yes.
That's what that sounds like. Yeah, I think usually those are just to give you a general idea of trending. You know, is it steady or is it volatile, right? That's about all you can get from those. Is it generally moving up or down?
Okay, up or down, all righty. There's another question. Beside half full circle, what other useful symbols do you find to differentiate groups like bad, okay, best?
Bad or what? I'm sorry, I missed that.
Bad,
oh,
okay,
bad, okay, and best. Okay, I see that
best.
one.
Yeah.
Yeah, I think symbols need to be simple, right? And so circles are really easy. You could also have something like stars, for example, for things that are good if you're trying to highlight what's good. But it's often you're trying to get to the one extreme, like what's the thing that's bad that you really need to pay attention to, or what's the thing that's good that you really want to celebrate, right? You're not usually trying to show all of them or focus on all of them at the same time. So I would lean towards which extreme are you trying to highlight and figure out what's the best symbol for that extreme.
Okay, thank you, Kristan. We have about a minute or so. One last question. There are a lot of tools for data visualization, especially now with all the open sources resources. So let's say somebody wants to learn about data visualization, so want to play with it a bit more. How would you even find what tool to use and learn about it, what do you think is the best tool to learn, if there is even a one called the best
Oh,
tool?
gosh. I always just fall back to Excel because it's on my desktop. There are a lot of places out there you could play, right? And I have to admit, I don't spend a lot of time looking at them. But you could look for what's popular. You know, there's always somebody doing evaluations of the best tools.
Mm-hmm. Yeah, and the other thing is Excel is here to stay. It's not going anywhere, is it?
Doesn't seem like it.
All righty. And with that, I think thank you for the wonderful presentation, Kristan. It was a very insightful session, and I see a lot of people enjoying the session. Thank you for joining us, our very first MinneWiADS conference, and doing this data visualization presentation. And thank you to all of you for joining with us today. So next is the lunch, and have a break, having lunch, enjoy your lunch, and don't forget to network. That's the other part of these conferences. Even though we can't meet in person, you still have the opportunity to network virtually. Thank you, everybody. See you at the next session. Bye, Kristan.
Bye. Thank you.